Assalamualaikum and hi everyone. In this lecture video, we are going to discuss curve slope at a point. The curve slope at a point can be defined as the gradient of tangent line at the point of the curve. Assume that PT is a tangent to the curve at P, and let P be a moving point along the curve AB. When P is moving from A to B, the tangent to the curve is also moving. Let's say now we have our point P is here. Then you will have your tangent line like this. So when P is moving, the tangent also moving. In other words, the gradient or the slope of the tangent to the curve is changing, and this tangent can be found by dy dx. Okay, now let us look several examples. Examples where the form of questions that you may have in the assessment. Let us refer to tutorial 3, applications of differentiation, where these tutorial 3 questions are provided in the column. Okay. Let us look at question 1a, where in question 1a, you have y equals to 2x squared minus 4x minus 8, and we want to find the gradient at x equals to 3. So we have y equals to 2x squared minus 4x minus 8, and we can find dy dx. It is equals to 4x minus 4. And in this case, we want to find the gradient at a specific point where that point is at x equals to 3. So what we have to do is we will substitute x equals to 3 into dy dx. So dy dx, it is equals to 4 times 3 minus 4, where this is 12 minus 4, and this is equals to 8. And this is the answer for question 1a. Next, let us look at question 1d. In question 1d, you have y equals to 1 plus 2x squared and x equals to 9. And we want to find the gradient for the curve y. And first of all, what we have to do is we will rewrite y, where 1 plus 2x squared can be rewritten as 1 plus 2x times 1 plus 2x. And then we expand this expression. 1 times 1 is 1. And then we have plus 2x plus 2x plus 4x squared. And then we can simplify this as 1 plus 4x plus 1 plus 4x plus 4x squared. So what's next is we want to find the gradient, where the gradient is dy dx, where dy dx is 4 plus 8x. And in this case, we want to find a specific value for dy dx, where we can find it by substituting x equals to 9. So substitute x equals to 9. Then you have dy dx. It is equals to 4 plus 8 times 9, and it is equals to 76. The third example, let us refer to question number 2. In question 2, we want to find the gradient of the curve y equals to 5 plus 2x minus x squared at the point where the curve meets the y-axis. Okay, if you remember, when we have a point on when we have a point meets the y-axis, it means that the point is on the y-axis here. So what happened? We know that any point on the y-axis, it will have the x value is 0. Because, sorry, we will have here x is 0 and y value can be any value. Because it is not stated here what is y. We just know that the point is on the y-axis. So from there, we know that x, it is equal to 0. So we know that x is equal to 0. And we want to find the gradient of the curve y equals to 5 plus 2x minus x squared. So we find first dy dx, where it is 2 minus 2x. And from there, we can find a specific value for dy dx, where we have to substitute x equals to 0. Then dy dx becomes 2 minus 2 times 0, it is equals to 2. So this is the final answer for question 2. Next, for question 4, we want to find an equation of the tangent line to the graph fx equals to 1 over x at the point where x equals to 2. Okay, let us observe what are the important informations that we need to take care of here. First of all, the objective of the question is to find an equation of the tangent line. It is an equation. An equation of the tangent line, we know that it is a linear equation, where a linear equation is represented by y equals to mx plus c, where m is the gradient of the line, in this case the gradient of the tangent line, and c is the y-intercept. And you are given that fx is equal to 1 over x, and we want to find the equation of the tangent line to the graph at the point where x is equal to 2. So what we will do here, we have fx equals to 1 over x, where this can be rewritten as x power of negative 1. And from there, we know that the gradient of the tangent line is given by f prime x, where f prime x is negative x times negative 1 minus 1, where it is equals to negative x power of negative 2. And this can be rewritten as negative 1 over x squared. And the specific value for f prime x is, we have to find f prime 2, because we want to find the equation at the equation of the tangent line at x equals to 2. Then we need to find f prime 2, where f prime 2, it is equal to, where f prime 2, it is equal to negative 1 over 2 square is negative 1 over 4. Okay. We know that f prime x, it is m, which is the gradient of the gradient or the slope of the linear equation. Okay, based on this, then we now have the m value, but we don't yet have the value of c, because when you express the equation of the tangent line or the linear equation y equals to mx plus c, you must have in this case, you must have a specific value of m and a specific value of c. We already have the value of x, which is x equals to 2. Then we need to find, okay, we have here y equals to, from y equals to mx plus c, we already have the value of m, where m is negative 1 over 4. We also have the value of x, where x is equals to 2. This is negative 1 over 4. But we don't yet have the value of c and also y. And in this case, we can find the value of y when x is equals to 2. Okay, you have fx. From the question, you have fx, it is equals to 1 over x. And we know that fx is a function in terms of x, where fx is the y value. So then in this case, we can find the value of y when x is equals to 2. So this is equal, therefore y is equals to 1 over 2. Okay, what's next? So now we have the value of m, we have the value of x, and we now have the value of y. So from here, then we have, from here we will have y is 1 over 2, 1 over 2, and then we have m is equals to negative 1 over 4, and x is 2, therefore we can find c, where c, it is equals to 1 over 2 plus 1 over 2 equals to 1. Okay, so we want to find an equation of the tangent line. Remember, it must be in the form of a linear equation where y is equals to mx plus c, and just now we found that m is equals to negative 1 over 4 and c is 1. So y is equals to negative 1 over 4x plus 1. So this is the equation of the tangent line to the graph fx equals to 1 over x. Okay, next example. Let us refer to question 6. A curve is given by the parametric equations x equals to t plus 2 over t and y is equals to t minus 1 over t, where t not equals to 0. And here we want to find the gradient of the curve when t it is equals to 4. Obviously here, you need to perform parametric differentiation. We have x, it is equals to t plus 2 over t, where this can be rewritten as t plus 2t power of negative 1. Therefore, dx dt, it is equals to 1 minus 2t power of negative 2, where this can be rewritten as 1 minus 2 over t square. I want to rewrite this because later I know that I will use something like chain rule. So this can be rewritten as t square over t square, because t square over t square is equals to 1 minus 2. Next, you are given that y it is equals to t minus 1 over t, where this can be rewritten as t minus t power of negative 1. Therefore, from here, we can find dy dt. We find dy dt, not dy dx, because y is in terms of t. So dy dt, it is equals to 1 plus t power of negative 2, where this is equals to 1 plus 1 over t square, and this can be rewritten as t square plus 1 over t square. Okay, what's next is we want to find dy dx, because the gradient of the curve when t equals to 4 is dy dx. So dy dx, it is equals to dy dt times dt dx. Dy dt, it is equals to t based on our previous solution. Dy dx is t square plus 1 over t square. And the one that we found just now was dx dt, but in this formula, we need to put dt dx. So from here, it becomes t square over t square minus 1. And in this case, we can simplify this. Then it gives t square plus 1 over t square minus 1. So we need to find a specific value for dy dx, and in the question it is given that we need to find the gradient, where the gradient is dy dx when t it is equals to 4. So we will substitute t equals to 4. So 4 square plus 1 over 4 square minus 1. And from here we have 16 plus 1 over 16 minus 1. Sorry, this is not here. Just now we have, I made mistake just now here. This is supposed to be t square over t square minus 2. So we need to make correction for here. So t square plus 1 over t square minus 2. Therefore, from here, we have t square plus 1 over t square minus 2. Therefore, 4 square plus 1 over 4 square minus 2. So 16 plus 1 over 16 minus 2. Then we have the final answer is 17 over 14. So this is the answer for the gradient of the curve when t it is equals to 4. Okay, that's all. Don't forget to do the exercises.